Maybe. Might be dark. Might be too dark. I'll turn the light on. Oh, be right back. Oh, lots of USB devices changing in the Windows update, I guess. Let's see. Webcam. Just fixing my webcam in OBS, hopefully. Oh, there we go. It's kind of working now. Hello. There we go. All right. Well, that's as good as it's going to get. So, I've been helping somebody on Reddit recently, and there we go. Let's see. I think it's this guy, Koth, from Reddit, was having some issues with his server, trying to learn Linux. Maybe he's in Twitch chat. I'm just going to pull my Twitch chat off to the side, too. All right. Oop, hey, we're live, dude. Not sure if his stuff is gonna work or not, but we're gonna try and remote into this guy's server, and he can give me the login details, and I'll drag this off to the side and log in with Putty. I got quite a lot of logins here for all the things. I don't do these live streams very often where we're doing computer system installs, kind of a new thing, something I wanted to do previously, but hadn't gotten a chance to do it quite yet. Say hi to the microphone. I can't really hide it any better than that, but it's there. Let's see what we can find. So for some background history on this, what we're doing today, here's the Reddit post that he posted. He's got a HP ProLine ML310 G2, and fairly noob. Hey, we all start somewhere, dude. I started in the same place and was mostly using canned tuna Linux distros that are pre-configured. And years and years ago, like 15 or so, my sound wouldn't work when I tried to use Mandrake at the time. Hey Timmy, I'm live streaming Linux stuff.
Are you busy?
Yeah.
Fuck.
Yeah, busy.
Can I roll that?
No. My roommate needs to get his driver's license. He's spending all his money though. So. Trying to work out here to help him get it set up. what's the other one? Um, let's see here. There we go.
Okay, I'll take over the live stream.
What do you need? Delivery? Yeah. Fortunately, you don't know how to do what I'm doing.
I can wing it.
No, I'll be an hour, man, probably. So we'll see. Where is Discord? There's the Discord. Okay, all right. Okay, yeah, we're all set up. So that couldn't be helped. Got his IP address on the stream, but you won't see the password. So that's fine. Okay. Okay, so I'll show this, right? So here's the terminal. I just logged in, and typically what we do to share a session, so that anybody that is logged in, right, LAN, anywhere, separate sessions, as long as it's the same user ID, the initiating person can type screen, and that'll start a virtual terminal, right? You can disconnect it from by typing Control A and D, right, and then reconnect to it by typing screen-X. Right, so screen-L, I think, or nope. There's a way to list the sessions. So just type screen-X. Excuse me. Yeah, I can't be helped. I'm a little quiet on stream, so maybe I can turn the volume up. I don't know if that'll help. I'm using Windows 10 for this because it's already set up, and I just game with Windows 10. But I do a lot of remote stuff with this, and through that, kind of figured out how to do a lot of management with Windows, or with Linux from Windows. So now I have no idea what the hardware is other than what was mentioned in some of the discussions, but we'll repeat some of the steps. So we got a list of the PCI Express bus. We know that the compact RAID controller was mentioned, right? Right, we'll pipe that to a log file, and then we get a log file. We can read it with nano, and this lists all the drivers that are in use, right, that are relevant to the hardware in the system. So, you know, later on we might need to know what the driver is for the Ethernet controller. Make sure that's included. What else? So the VGA controller is an AMD really old Rage 3. Typical on server hardware. They don't really have a high-end graphics card. Doesn't have a device driver in use, but you know, it's a live CD, so that's not really too much of an issue. And again, it's using the HPSA driver for the RAID controller. It does appear to have driver in use, so we knew that from the. Okay, so we've got 72 gig SDA. It's a GPT partition. Our friend here that's invited me to do this for him was trying to get it to write to the disk. Yeah, that's another thing too. Well, some of the older hardware doesn't work well with newer software for graphics cards for doing frame buffer stuff, because a lot of it's moved to supporting UEFI bias, and the UEFI bias frame buffer works differently than legacy bias systems. So some of them don't work on those types of hardware with the graphical Plymouth, I think it is. Boot Splash is the new one. So yeah, that could be part of the course with hardware that you're using. And this is a legacy bias system too, and we can see that by typing mount. That's really all you need. And if you don't see a file system mounted, I'll show you on one of my systems that's named EFI something or other. Oops. And this is my my main NAS server. Right. So this is a dual Xeon 2690 V2, 10 cores each. So she's a beast. Pretty busy. Not very busy today, but been very reliable. Runs NFS as well. Right, it's got an 8 drive, 8 times 10 terabyte a RAID. It's basically equivalent to RAID 6, but it's all ZFS, and it is a UEFI bias system, which has been fantastic. So mount, oops, and a lot of file systems. So the one we're specifically interested in for UEFI is this one, EFI bars, and that will only mount if a system is booted with UEFI active. And these live CDs support it, but as you can see, you know, EFI bars is not mounted, and that's fine. You just typed a bunch of random crap because I'm in the putty console. My mouse is a little too close to my printer on my desk, so I'll try and move some things a little over and not bang on my mouse. So legacy bias, hardware that we're using. Not really sure. You know, it doesn't matter what the sticker on the box says most of the time. But sometimes you get hardware that doesn't play nice. Maybe old, maybe getting a little tired. Could be just it was never had the firmware updated, the BIOS updated. But you know, there's all those things that you got to look at when you're trying to build an install for a server that you're unfamiliar with. You know, the previous DevOps admin guys had all of that information in a logbook somewhere, and you know, they probably put it away, didn't care about it after 8 years because it was easier to just get a newer one with a new BIOS that worked and not support legacy systems for like 8 years or something. So it's nice getting your server on uptime porn, but yeah, and that's Koth here mentions it's got HP needs, you need to have an active warranty to get their newest BIOS. So you know, if it's vendor restricted and all of that crap. So, but you know, you can do as much as you possibly can with pre-configured software in a lot of scenarios, up until it becomes an obstruction to getting the machine or server to cooperate and really, you know, adapt to what's necessary that would still make it useful for educational reasons, or you want to learn how to use it. And like our friend here's having problems with his RAID controller. So what we're going to do is we're going to just check parted again, And we're going to redo the partition on this thing. It's a logical volume, you know, because it's hardware read and SCSI and so on. We notice that the sector size is only 512 bytes. So it's not a 4K logical sector disk or the new advanced format, which is fine. That's something to note for later uses with ZFS, for example, where you have the ability to tune how the disk is written to by the software, which block sizes it will write so that it gets optimal performance and all of that jazz. But Parted is smart enough to be able to work around all of that, as opposed to, say, FDisk. And Parted knows whether the disk has a certain logical physical sector allocation size and what is an optimal alignment for a certain amount of megabytes. And FDisk just doesn't have that capability. And FDisk can do this, and it can still work with MS-DOS partition labels. So we see here P, H for help. You know, it can get complicated or really simple, right? And the menu kind of looks daunting. The man page is a mile long, but none of that matters. There's, you know, the basic commands are usually good enough just to get you by. So we'll want to remove a partition. It's RM1, P, you know. Let's try an MS-DOS, and we'll see. So yes, P, and there was nothing on the server from what I was aware of apparently. Our friend was just trying to test to get this thing to write on the drive offered by the read controller. And 2 times he tried, it wouldn't work. So we'll try it and we'll see if we can help out. Maybe it'll work, maybe it won't. So we'll make a primary partition, ext4, oops, T4, just because it's the newest of the 3, 2, 3, and 4. Start at 1 megabyte and end at 100%. There, that's done. And it's got correct flags, LBA because it's an MS-DOS partition label. And we'll quit. And it writes that automatically. You don't have to press write or save or so on with Parted. So now if we type Parted L, we can see that, you know, it's configured as primary. It's got no file system name, file system flags, not bootable, but it'll suffice for a basic test. So SDA1, and it's the partitions that you want to format, not the full block device. So as can be seen by SDA1, and every additional partition will be like 1, 2, 3, 4, and so on each device. So SDA1. So it's creating the file system, which is encouraging, because this would or should really error out if you were completely unable to write data to the disk. So now we'll go ahead and we'll mount it. SDA1, mount Gentoo, and we're going to check if it's mounted read-write. And it's mounted with read-write access. So there's no errors mounting the file system. That's a successful test. And it's saved. There, we've written data. So we'll unmount it. Let's try GPT. Okay, so RAM1, and why don't we actually make the we'll make or create a proper partition table, because that first result looked encouraging. And I'm just going to look up my guide on Gentoo forums for this. Handy to have written helpful tutorial guides for people, so that you can go back and reference them later when all of your stuff vanishes and it gets stolen or something. So this isn't a computer that has UEFI bias, so we do have to consider that when making the disk partition table, so that it'll be compatible with legacy bias. But I'm going to use my guide that I have from configuring a UEFI bias boot system as some comparative reference for commands. If I can find it, here it is. Okay, so I'm gonna paste this to our friend Koth, who may be in chat, and I'll paste it to the Twitch chat. Ooh, we got some viewers. All right. Where is my chat? Come here, chat. Oh, my chat was over here. Here we go. So here's my guide that I had written up on that, because as is mentioned in that post, some of the stuff that Gentoo does in their default partitioning is meant to accommodate both on the same setup for a fallback, perhaps, or for migrating systems. But you know, if you don't need that legacy bias stuff, you can just go ahead and use purely UEFI. So we're pretty much going to make like 100 megabyte partition, but we're going to try GPT. So now GPT has a couple advantages. Is that it supports really nice partition UUIDs that can be used for disk mounts in FSTab, or by tools that create init RAM FS files that will boot more advanced file system configurations. So let's go 128, because I think it's like what's 1024 divided by 4, right? I try and round it off to the proper amounts, or 1024 divided by 10 would be 102. That's weird, because 1024 is a gigabyte, right? So I don't know, we'll go close as that just for the heck of it. Say 110 or 112, I don't know. Good enough. So we have to set that as bootable, and so that might not work with legacy bias, but right. So then we'll make a swap partition, and because Parted can define sizes in megabytes, we go from 112 to what's 2 gigs minus 112, or 2048 plus 112, 2060. almost big enough. Take away 19, 48, 212 plus 2160. There we go. Exactly 2048 or 2 gigs. So that's good. And ext4, and we go from 2049 to 100% of the remaining space. And it's going to correct it for us to make sure that it's not out of bounds. And then there we go. Finished. So we'll do SDA1 and SDA3 as ext4 for a basic setup. Yes, I'll write it. SDA3. Okay, now I'll switch back to Koth here in Discord so I can watch what he's saying if he says anything. I think I can probably minimize OBS. And we're going to grab the install stage tarball for Gentoo. So we want, we'll try this one that I'm most familiar with and works extremely well is a system install. Definitely worth using. We've all got fast internet here on the west coast of Canada and the US. Apparently our friend here is from the same time zone I am, which is an awesome coincidence. So, and we'll cheat and we'll grab some commands. So we'll need this, and installing stage 3, unpacking. Now, this extra stuff is useful, right? Because it will preserve a lot of the extra file system attributes that are in the tarball. And hopefully this doesn't error out because everything else looks good. One thing first. So we'll mount the boot 100 meg partition to a subdirectory of the working directory that we're going to build in, which is mount Gentoo. And you can see that, right? This under here basically is the contents of that RAID drive, which is our current working directory. So anything that gets written to boot will get written to that that partition specifically. Well, you don't mind, I'm gonna have a smoke. Nasty habit, but you get old bored compiling software and lose a little bit of hair and your teeth. So we're writing data, but he says that it runs out of space before it finishes. So that could have been the partition configuration or file system, the way it was formatted. I'm not sure, but maybe doing this will help clear that up for our Fred Koth. I'll post the Reddit thread in stream chat also. Anybody wants to contribute, it's there. Still going. Yeah, I got a vape pen I gotta use, but it's not full of something that doesn't get you high or stoned or baked. You gotta buy a different cartridge for it, and not in the battery, I guess. I was told it was a battery. They have a different customs and things you can get access to here on the west coast of Canada than further east where I grew up. But always did like the west coast. So it's chugging along fast as it'll go. So typically, if I'm going to do this, and this is probably really old hardware that he has, probably maybe 64-bit Pentium 4 or newer, possibly, I'm not sure. I'll use a new computer to do this and build a system in advance of the new computer. In advance using the new computer for the older hardware, and a lot of the steps to do that are very similar to this. 64-bit Pentium 4. So like the older hardware, it takes a long time to compile software. So, you know, like this server of mine that I have here, right? It's got 20 CPU cores. You know, I've built installs for Gentoo before and given them away on Reddit. Or one that I built recently. Right, that's was an install that I built for Juniper NSM appliance that I had custom installed Linux on using USB SATA bridge, and you know, made sure that it was updated, ready to boot, and so on. But and then afterwards, you just make a giant compressed file, basically very similar to the one that was used to unpack this file system. Right, looks quite similar, yeah. And after that, on the hardware you want to use it on, configure it by configuring the kernel, configuring the FS tab, any usernames you might need, and you know, also configure the bootloader and IP network settings. And you can clone systems doing that very easily for older hardware as well. So, you know, naturally, like, given that I've got a ZFS array in this thing, you know, I use my ZFS array as much as possible for data storage things. Home, I just used home because it was an easy one. It's got in the way a couple times, but yeah. So Now let's go and we'll get the other stuff that we need. So a lot of the stuff you can skip if you really know what you're looking for. This is something that's necessary. Mirror select, not necessary. And making note of the stuff that we're using for systemd. Now the last time I did this, I remember the directory had changed, but apparently not this time. So and this is where you set your mirror directories that Gentoo is going to use. And I think that's what it is. And they've got them separated by domain in America, CAUS, and breakdown. So if you're only on like IP version 4 and you're having problems with IP version 16S, maybe pick one that doesn't have that. But we can see here if he does. But we'll leave it as North America for now, given the time zone. So he does have IP version 6 because this is publicly routable. Why it's a 64, I don't know, but you know, maybe that's routable. Maybe it's actually there 128. So we can go real high tech with this one, so to speak. So it'll use the IP version 6 as well. So we'll just leave it like that. Okay, so we've got the mirror mounted. We've got the rsync servers done. Let's copy the DNS info from the CD. Oops. And not Google search for it, but actually use copy and paste. And then it's pretty much this. Mount the virtual file systems. This is one of the reasons why, despite having used Linux for 15 or 20 years, I still use PuTTY. It's just so much quicker. Copy and, you know, you left click or right click and hit enter. The other terminals in Linux require you to highlight copy and then highlight paste. So this is quite a lot more pleasant and a big time saver for doing this if you do it frequently. So there we go. So that's our basic environment set up. And we will root into our new environment, which basically changes the root directory to be a subordinate directory, and there we go. So that's what you would see on the hard drive if you booted from it. And we have to update the environment to recognize that we have rooted. Or it's etc profile rather. There we go. And then environment update, and is usually an alias for environment profile variables. But we'll so reinitialize that, and then emerge -web. Now the tab completion or bash completion in Gentoo is fantastic. There's a lot of developers that use the distribution because the Vim integration is excellent, and all the plugins you can get for it. Because the software is not pre-built, there's like 90,000 to 100,000 or more packages available, and you just build what you need. Build around problems, build things to fix problems. But in doing that, you give up some of the convenience of having a system that is pre-built, and it does take a long time on older hardware to build one of these. However, a newer system, I don't know, 6th gen Pentium, or something like that, 2nd gen i7, you're looking at like a couple hours to build a bootable install. And this thing's probably got 2 CPU cores. It's an older generation, so the install's going to take quite a bit longer. But you never have to start over, as long as you know how to do this part of the installation. You can reboot to the CD, remount the file systems, and proceed to repair anything, as long as you can get those file systems mounted correctly, and perform the chroot, and the chroot works. Hey, Mr. Bontuck. Yeah, I lost my voice a little bit. I've been smoking these too much. So we're helping Koth with a server. It also goes as fast as the disks. So there is a trick that you can do for some systems that helps with speeding up the disk write access when a system is compiling software. So we'll look at that while it's doing this, so that everything that's written by a software compiler doesn't have to go to disk, but it goes to memory or TempFS. So it's like a RAM drive. This is Linux's interpretation of RAM drives. And what we can do is we can mount a partition that's like 4 gigs in size, and basically create a RAM drive from it and use it as temporary storage. But knowing how much memory you have first, which is not really enough to do it. We're not going to be installing anything really, really heavy in this. Like you wouldn't want to build, say, LibreOffice or some of the bigger programs with only 1 gig of memory. It might not work. That's one of the reasons too that pre-built systems can work better. But the older hardware, some obscure edge cases like this can create issues where maybe something's not cooperating. Like the boot splash screen for this wasn't working when he tried booting Ubuntu. And how do you get past that when all it does is it loads a graphical interface? Well, this is really how you get past it, but this still has limitations based on the hardware provided. So we've got 990 megabytes of RAM to work with. We'll try and make it work as best as we can. You just don't compile a lot of stuff, a lot of compiled jobs at the same time. Try to keep it to like 1 or 2. And it can still be really efficient. And you might not get a great desktop out of this. I've had KDE, for example, running on 500 megabytes of RAM, so it can be pretty lean. But the ones that feed you, by the shovelful at first, and then want you get you coming back for more later by giving you thimblefuls later, right? You might be too much for your system to handle all at once. As a great example. So if we had the ability to use like 2 to 4 gigabytes of memory, that would greatly speed up the amount of disk writes that were necessary to write the temporary files to build software. But that's not the case here. So you can tune the system configuration around that by editing the system build files, system profiles, or system software build profiles, I guess would be another way to put it. Right, and there's a pretty generic common set. And this is the default template, but like to look at my server by comparison, it's got everything set, and it's got 128 gigs of memory. Like you can get pretty specific, like automatic C compiler flag detection for specific CPUs, which is just native, or you can set it specifically if it's not cooperating with auto detection. You know, like how many build threads do you want to run at one time for a single package? You know, enforcing certain features. And you know, these are two of them that I would not recommend doing without. Is specifically this one, features. It adds some neat features for consistency enforcement and changing the way that Gentoo detects breakage when upgrades are done. So that's the preserved libs being disabled, is the breakage detection thing. Just altering its default behavior to the more traditional behavior. And we'll have make ops as well, and we'll set that to 2. And we'll see how it works. Auto clean, so it'll automatically remove any stale packages that are left over when cleanup time comes. We do a card reusing. Input devices accept licenses. Our grub platform is not going to be UEFI, but we can fix that. Curl, we only want 64-bit, and this is optional for CPU-specific stuff. Setting the SMID instructions on the CPU to build specifically for that CPU. So the software is the most optimized, and typically you use that with the native notation in the C flags or common flags field in variables. We're gonna comment this out for now because we want to try and build this guy, our friend Koth, an installation that will be portable between different systems of Linux. So if you enable the CPU flags and you enable the native CPU detection, it will build specifically for one type of CPU. And then later, if you ever change your computers, you want to use this on a different machine, this build, you know, you can keep updating this for a very, very long time. There's people that have Gentoo Linux installations that are like 10 or more years old because they updated them, you know, semi-frequently, right? But, you know, enabling the March value and the Mtune value will make it build the software binary specific for a processor, and a newer or a different brand of processor may not recognize those. And what will happen is when you go to try to chroot into the directory after you want to try and configure it, it will give you a warning about legal instructions. And basically those are those instructions that each CPU possesses. So there's also a search program, one that's not included, called EIX. You can see it just comes with really basic stuff to start over. We're only using like 2.7 gigs of space, so shouldn't get too much bigger than like 5 to 9 gigs total. And you know, you got a lot of space left over with a 65 gig partition. So what we can do is we'll do a build to install EIX just after we check one other thing. So the way that you configure software on this version of Linux or distribution, to customize software is by using a system.
Where's the clerk?
Flags.
I know. I'll use the "May I help you" riff.
And
May I help you?
that are used to set those per package specific configurations. It's something that you probably use a lot with this distribute. Now, on mine, right, we've got package dot accept underscore keywords and package dot use, and the package dot end file is specifically for configuring that tempfs mount stuff. And not going to be using that here, so we won't add the file for it. But you know, we can see that file as described by the wiki page basically just tells where certain packages should be built on the disk instead of in memory. because sometimes they're too big, sometimes, because of file system attributes or security stuff or something, it won't build in memory. GCC will do that occasionally, but we're most interested in the .use, which, you can go through this package by package and notation keywords. They're subcategories by purpose, like line, for example. So line staging and all of the package flags that should be enforced that it needs to build with, per your own preferences or requirements. Like DevOps stuff, like Puppet, CF Engine, Postfix Admin, and other tools like those, miscellaneous stuff. And the other one is accept, and that's for keywording unstable packages. So, and there's a bit of regex involved, or regex logic involved in this. Is that a package that's notation or added like this will keyword every testing version available, and thereafter every new one added in that package or by that package when it's updated. Some of them you want to try and keep under control by only keywording a specific version to be used. For example, like ZFS. So I only want ZFS 0.8.1, and it will not install a newer version unless I actually edit that specifically in this file. And the SPL package used to be a component of the older builds of ZFS up until this version, but it's no longer used. However, the example is relevant. So the reason why I removed this package.use directory is because the other way of doing it is to create the directory package.use and then add a file to add your package specific configurations or for a package to that file. It's a pain in the ass to use it. Maybe some people like it. I just find it a total inconvenience. So we'll make a new file. Not really going to add anything to them yet. There's a few things I might want out of here. I'm sure I can give Koth all of this stuff later, but this one here is one that would probably be ideal. And we're also going to install a package for managing those flags. Fortunately, there's an incurses utility for doing that, and it's called ufed. So we'll install EIX and ufed, but we'll do pretend and verbose first and let it, check what's needed and present us with the options. So that the features flag that I enabled in that configuration file enables that more decorative. It's a candy option, but it prints a bunch of random strings out of the Python code. So as you can see, when I do it again, calculating dependencies, and it's got a bunch of little witty text here that it types in like Night Rider mode. Oh yeah, the video card. Yeah, we can change that to AMD or ATI. Where was it? We'll definitely remove the NVIDIA. We'll just leave it blank for now, but you can get more specific as you get into installing like the XOR graphics drivers. And I'm not sure what the graphics driver is for what is it. So we don't have LSPCI, so we need PCI utils as well. And a cron daemon. Thinking of anything else we might need. I don't know. That should be good for now. maybe Kernel Sources. Oops, I typoed that. You don't have to be an expert in Linux to be able to use Linux. I never took the typing class. Go figure. You know, just fat finger through it. And a lot of the commands are very similar between distributions. But this is definitely the way to get exposed to doing fundamental things early. And, you know, not having to rely on somebody else to fix your stuff. By building and configuring a system. So we're going to try and build at least a basic bootable system for systemd. Let's get our friend Koth here on stream. Say hi, Koth. Hi, stream. I've got a microphone, but I could probably hop on Discord and voice with him, but, you know, I'm sure you can hear me on the stream just as well. So, and this is compiling software in a nutshell. It's basically like a procession of commands to build software out of C program code. You know, it'll be great for me too to do this because I got a job interview on Thursday. And yeah, using this for some profile benefit stuff, you know, perhaps for the interview will be interesting. Not a lot of people know that you can do this in the IT management or IT industry. Maybe a lot do, or maybe a specific category perhaps would use this very well, or prefer to use this. I just like being able to have complete visibility of everything that's installed in my system as well. So like anything that is built by a package, I can go back later using the tools that are provided called eQuery and look at every package, every file that was installed by a package, what its dependencies were. If I have something that's broken, I can use that for you know, research to attempt to fix something without having to reinstall the whole system. And you don't get that capability with pre-built distributions. This is also called rolling release, but it's from source-based rolling release. And as Unix and Linux goes, this was inspired by I believe BSD, NetBSD, FreeBSD. I think mostly FreeBSD in its ports package management system. And ports is basically from source, but it has a very rudimentary package tracking system for keeping track of things that were installed and what installed the package required it. And this was just sort of the next step towards that and doing it with Linux. You know, like 15, 18 years ago. And I just happened to run across this in like 2002, 2003. And it really just allowed me to do everything that I wanted to and nothing more. Or a lot more than I would have been able to do. To tune things, custom build installs. And yeah, it is a lot slower because it's an older machine, but you know, from what I'm seeing here, I see that there's no problem at all with the RAID controller now because it's clearly rating data. There's no errors. The install started. I've got to build grub, build a kernel, and the kernel will be pretty easy to do. It'll be really basic. If we do happen to have a problem where the system won't boot from GPT, you know, we still have the data. We can go back to the live CD, make a backup. Yeah, maybe Koth says it might have been one of the PCIX slots for the controller, possibly. That's certainly possible. can be able to make backups using those tarballs, and reconfigure a disk at will for any system and still have your installation intact. You know, the console, despite, you know, the displays that you'd see online, a lot of people say using a graphical desktop with Linux really just leads you back to the graphical desktop being an add-on or utility value. Maybe you want to watch a movie. Well, yeah, it'll do that, great, but you know, you can't do some of this low-level stuff without the console terminal. Just doesn't work as well with the graphical utilities. Or distributions like Red Hat Enterprise Linux, for example, that provide those, or SUSE, they provide those. You know, perhaps they're pay per prescription or pay for subscription type service perks or offerings for software. You know, but you don't get to see all of these patches being applied, or be able to customize the patches that are being used in some cases. For example, like Wine. To get Wine to work, there's 24 different flags that you can build to build Wine for a specific graphics card. And what API it uses. You want Vulkan added, you know, recompile it. It'll recompile everything that it needs to be able to make it run. You know, you want to remove that Vulkan later, you know, change the flag, rebuild it. And then after rebuilding it, you can go back and remove everything that's not required anymore by having done that. Just purge the extra bits out, and you have, you know, horizontal consistency or linear consistency, however you want to look at it, between the most initial and, you know, most recently added software packages. Because consistency is a happy system. Sort of like Bob Ross and his happy trees. All right. So why I'm doing the kernel sources first is because really what we've downloaded to start this is a pre-bootstrapped compiler environment. The bare minimums necessary to compile software, which is, you know, quite a significant list of important software, but nevertheless, that's what it is. And it's good for the auto detection and feature support for the software that you're going to build, to be able to reference a set of kernel sources that have been configured already and possibly compiled, and then start building and adding your important other stuff like your bootloader and that other software links like a cron gaming. And this is, you know, so that software builds against this version of the kernel. And again, it's to address consistency as well. So I do have a base kernel configuration that I can certainly use here. So once it's installed, I'm going to wget this file. So the config that I have for my server has like all of the good stuff set for being able to do advanced routing, virtual machines, all of that jazz, or you know, necessary things to run different softwares like Docker. It's got all of the little bits set to do that, and process management things, and IP tables. You know, so graphics card settings that are useful, and you know, some of that stuff might have to be changed for this specific system, but it's a good starting template that's been very stable. and it usually saves an hour of going through all of the little menus to do a kernel config. And we're going to save this file after downloading it in the root directory, and then copy it and name it a certain type of dot file or hidden file that the Linux kernel source directory will recognize. And so unfortunately today I have juice because I'm getting damn thirsty. Okay. Always have a big jug of juice. And I've got, we'll try just HTTP. There we go. Rename it. And this is also like a lot of the time how I do kernel config update management. It's all done through text files. A lot of this is just manipulating text files and using a console text editor. And we can see that the current kernel version is highlighted as active. The symlink is updated and accurate for 4.19.57, which is currently stable. So, important things actually before we do this. We're just going to exit out of the okay. So that's the one that's got the good stuff in it. Looks like we got a couple of extras open here that I'm just gonna close them. It's probably an easier way to do this. Oh well. Yeah, there should be one session per shared, but for whatever reason it just mucked up. But it's not a big problem. So we can use lspci after we install this package. So we'll take all of this and we'll copy it into TextPad or Notepad++. Another reason why doing this on Windows adds some really great utility. Just do this. Yoink, or here actually. -K. Type lsmod. There's a lot of crap in here, right? Like, you know, it's a long list, but whatever. You know, take this stuff before you go into your kernel configuration template. My server kernel config is also set up. We're using QEMU, which you don't really have enough memory to really use, but still, you know, if you want to use that on a different, newer system with more memory at some time, that might be something you'd want. And my kernel config is also published too on the Gentoo forums. If you look in my comment history for the config dump for that server. Anything else we need? Let's just check the message too. So this is a log of the live CD boot. Gives us some really good information with BIOS versions and all kinds of other stuff. Firmware versions for controllers, you know, if there's any ACPI issues, warnings, errors. Lots and lots of crap in here that's very, very advanced and sometimes not. And sometimes very useful. PCI Express device initializations, memory controllers, all of that low-level crap. This is where it logs it all. If you add a new device, type dmessage, and it will, you know, show you the initialization for that. Here's the RAID controller initialization, right up here. And it says it attached dev disk SDA. Good to have a review of this. And as you can also see, there's a lot of these drivers that are being initialized that aren't actually offering hardware. They're just there. They were added. But that's because of this being you know, a CD meant to boot on all manner of random systems, right? And you know, every time one of those drivers is added, it adds a memory address range that it's supposed to be in control of. You know, being able to slim that down and customize it can prevent software errors and hang-ups, increase runtime and reliability. You know, they did this distribution on the NASDAQ stock exchange 10 or less years ago, and you know, they did it because they could customize all of that stuff. So we've got all of that, and let's check the CPU type. So Pentium 4, 2 cores. And we'll load up the config menu for the kernel. And it will load the config from that file that I added. So as you can see, like, there's a lot of this general stuff that's preset, like that kernel config proc gz, that's an option. And there is a lot of this stuff. And you know, nobody should be expected to learn all of this at once. I don't know what all of it does myself. I know quite a lot of it. And like namespaces, control groups, you know, like huge TLB and CPU set is one that I need to add on my system. Processor features. And want to make sure that just for this, we'll compile a generic kernel that's not specific for any processors. So it'll just be generic 64-bit. We could go P4, but you know, maybe we will. We'll go P4. Okay, so we also know that the couple of the drivers that we looked into previously was the driver for the RAID controller And the drivers for the frame buffer will need to be changed in this so that it can display a terminal console on the graphics card driver. And we also want to look at support for the Ethernet controller. So SCSI and its low-level drivers. And the one that we're interested in is this. And because it's the boot device, we want to make sure that it's set as a star yes, so that it will load the driver when the kernel loads. So that will also find the file system that's necessary. I'm going to leave these other ones in here for random chance that maybe there's a later need to use them. But you know, a kernel that comes from Ubuntu for Linux would have all of this stuff. It would have it all. They just like shit can at everything. And sometimes that works well and sometimes it doesn't. Often it may. But the tuning stuff, in my experience, being able to tune it out and remove, you know, can really slim things down. So this is all like drivers for legacy IDE devices or PETA from, you know, the eras of like 2005, 2007 or earlier hardware. And a lot of this stuff, you know, nobody with a newer computer really even uses anymore. It's pretty much just handled by the SATA driver. But since we got an SCSI controller in this thing that's managing the volume, we probably don't need anything else but the Intel driver. Promise SATA, no, not needed, not needed. Gonna look at help on this. There. And what was next? We'll look at network devices. So we have general support for a lot of different network devices. You know, nobody's going to use fiber channel on an old server like that, so you probably don't need that. I mean, if you ever do get a fiber channel card and you're using ISCSI, you might need it, but that's expensive stuff. Okay, so Ethernet drivers. This driver here is for the 10 gigabit Ethernet card that I have. I'll leave that in case you ever decide you want to get a 10 gig card, because they are very nice to have. It's like having an SSD on the end of a computer on an Ethernet cable. So it's a Tygon 3, and you know, we want the TG3 driver. So that's what this is. It's TG3. And then we can remove some of the other ones, like Emulax. And some of these get added when you import a config, and you'll never need them. Generic stuff, like, you know, you won't need Mellanox drivers for a pretty standard machine. You're not doing like 40 gigabit SAS networking or anything like that. So that concludes our minor adjustments of the network config. Some serial support stuff, IPMI, random hardware generators, or character device things. That's pretty much all set. We're looking for graphics drivers or graphics. Graphics support. Okay, so that's all included, AGP support. Which one was it again? It was a Rage XL. Sometimes this can be good clues too, using these Rage XL PCI. And we'll remove the UEFI stuff, UEFI code. Since we're not going to be booting a UEFI machine. You get a nice dual penguin logo when you boot the system. Do we have a sound device? I don't believe we do. So no sound. Okay. So we'll just leave this the standard config that they generally use, which is configured pretty much for HD audio. But you know, if you got a PCI device you want to add in later, you can add it. Also supports USB audio MIDI. Now this is required to run capture devices like microphones with OBS, so it could be useful. Because again, this would be a portable setup you can use on a different system if you make a backup of it. Pretty generic USB support. And yeah. Okay, so there's a lot of the stuff that we have to do with device drivers is done. And we'll go to file systems. So this is an important one. You want to make sure that the file system you're going to boot with is included in the kernel binary. If you're not going to use an initramfs, which we're not for this, that's just not necessary. It's an extra thing that you have to consistently maintain alongside kernel upgrades. Very useful when it's necessary, but a lot of the time not always necessary. So we've got our language, regional support, you know, settings, support other things, basically set for English, network file system support. Support like squash fs and deflate zlib compression, which is deflate's needed for ZFS, so typically have that in there for that reason. ZSTD is one that's becoming more common. We also want to make sure that we have it's like partition support. There's a section in here for partition support. And what that does, okay, now NTFS you don't want, or MS-DOS, just VFAT. So that's really, really old Windows file systems, no longer really used. In NTFS you can get write access with the Linux write driver. This one doesn't do write access, so we'll exclude it. Security options, there's no hardening, just or no SE Linux, but you know, there is some generic good security settings. Try and avoid SE Linux if I can. And some of these settings also enable memory protection settings that were discovered and addressed to address the security CPU vulnerabilities with Intel CPUs and other CPUs that were having those problems like last year. A lot of debugging stuff is disabled, so it's a production runtime kernel. Anything else? I don't think so. Things are pretty much all set up for... Okay, so there we go. So that'll build our kernel. It'll run 2 jobs at once, one like 2 threads, and we'll build the kernel modules and also install them and install the kernel binary. Now this is going to take a while. This might be an hour on this machine. It might be 10 minutes. It's really hard to tell in advance, but you know, for perspective, it will work on a single core system too, but it probably, depending on the CPU, whether it's newer or it's an older one, like 6th or 7th gen like Pentiums, they're amazing, and they're only 2 cores, you know, but it's newer hardware, right? And like the amount of cache memory that a CPU has will determine whether it's just going to bottleneck trying to run more threads than it has cores, or more, you know, hyper-threaded processors than it has to be available to run threads. So, well, dual Pentium 3, yeah, you could do that on a dual Pentium 3. What's that? Like 4 process threads, or is it 2? Like, is it 2 hyper-threaded cores? Okay, yeah, so they're just single core then, right? You know, for the Pentium 3, or even this, you know, like if you get tired of doing the updates on this, because you'll be doing a lot of this with Gentoo. You know, I see no reason why Arch Linux wouldn't work, but you know, you do give up some finite control over all of those little tweaks that you can do with Arch, and just directly building software to your needs is more convoluted. It's like stepping backwards towards the pre-built sort of side of Linux. some would imply that that could be a thing. I might as well. So yeah. I have a video where I did kernel upgraded this on a first gen i7, and you know that kernel build took probably a good half an hour, running eight build threads, or maybe 4. So it's I used to do this back in the day on like Pentium 4 hardware, and you know you can think how old a Pentium 4 is when it's still pretty decent hardware to have, and I probably learned to do this on a Pentium 3, Pentium 4, Pentium 2. And it took lots and lots and lots of patience. The newer the machine is for using Gentoo, the better the results will be. But, you know, you can't always have that choice, right? So the older hardware, you know, you have the advantage of not having to babysit this as well. You know, you can queue up like a dozen commands, walk away, and check on it tomorrow. You know, maybe it stops in the middle of the night. You have to fix something that didn't build. But, you know, you just kind of set it, forget it, and once you get it booted, it's booted. As long as you don't break everything, then, and keep a backup. So there's no progress bar for this. That's one thing. So this is the quad, or what is it, dual 10-core Xeon, right? That's 2 threads, right? But I can zip through it with like 20. And it's only as fast as the disk that it's on. It's got a mechanical NAS spinner disk in it too. So there's that, but it's still writing really small files. You know, like that's 20 threads. That's using all 20 cores, not hyper-threaded cores. That's the difference between new and old hardware. And this server of mine is only like a 2nd gen Xeon. Yeah, it's all CPU with an old machine like that for bottleneck. Not really bottleneck, but that's all it'll really be capable of. Is what you could expect from, you know, like 15, 20-year-old hardware. But it'll chug along and it'll get its things done. Unfortunately, building the kernel is absolutely necessary to finish the installation steps. But, you know, you can see that if you had a newer machine to do this on, being able to pre-build this and then unpack the tarball and set it up, you know, or pre-build this with a newer machine, unpack it, and then do it on the old one, pre-built would save a lot of time, but probably save days, possibly. You know, days, of course, being worst case scenario, because it is a pretty old machine. You know, if I do 20 threads, I've done 20. Let's try 30. Just flying along. But you know, you build a proper server, you get proper hardware. And I really needed a proper server. So welcome to the other guys that have joined us. I'm not sure who Koth is in chat, or if he's in chat. Probably in chat. Commander Root, possibly. Ah, there we go. This is best done when you're watching a movie too. Even on newer system install, you can just like chain the commands back to back and walk away, and come back to something that gives you some typing to do to finish up what your intended task happened to be. See, starting with certain generations of processors, they also included, and I think it's like first generation i7-ish around there in Xeons. They added a hardware cryptography engine to the CPU itself, and that really speeds up a lot of tasks that a CPU processor would be required to perform. But the older hardware doesn't typically have that, so. Encrypted file systems, for example, won't work very well on old hardware because it uses that CPU crypto engine to do a lot of the decryption calculations. So that probably built in a minute, maybe 2 or 3 tops. This will probably be going for another half an hour. And this is the part of Gentoo Linux that a lot of people don't have the patience for, because they have the initial view that you have to boot the live CD and just use the console on the live CD, or not use SSH in a second computer, and then you have to watch this all. And to a point you do have to watch it all, but the other stuff you can get around easily by logging in from your desktop computer and using a third monitor or something. So it goes through all the categories and subcategory folders and compiles all the C files. Goes like Arch FS, sort of in alphabetical order, as can be seen from the goes through like Arch block, FS certs, and so on, sorted down the list to user, vert, and tools and sound in descending alphabetical order. MM is like memory management category of kernel code. Yeah, like a dual core 6th gen Pentium can build a full install to a bootable system with a console and SSH access in perhaps 2 to 3 hours. And that's including probably all of the little configuration stuff you have to do, including like building and configuring the kernel. Basically setting network configuration things. So if we added 2 gigs of swap to this thing and it's got a gig of memory, that's probably a good thing. Something else you could factor into is how big you make the swap file, depending on how much memory you have. And I kind of did that a little bit backwards, but when you got like less than a gigabyte of memory, or they're in and around, if you're using more swap than you have memory, well, you probably need a new computer anyways, especially considering the size of the disk. or not the size rather, but the speed of the hard drives, probably being older SCSI disks. You know, using swap memory on a disk this slow would not really be ideal. We're using a lot of swap space. A little bit's fine, but you know, more than like 500 megabytes of swap, or a gig of swap. You know, so or virtual memory essentially is what swap space is. Can really slow down an old machine like this when it starts running out of memory. Yeah, like DDR ECC is still kind of expensive for the older stuff. I've got a 32 gig kit of ECC DDR3 that I used for my server initially, but I replaced it because I got a 128 gig kit and it was different memory timings. So it's pretty much sits in this little thing on my desk, the Kingston memory, I think, or is it Kingston? Kingston, yeah. 32 gig ECC. Got it off of eBay. So you can find the stuff, but you know, if you're buying ECC memory for an older server, you might as well just get a newer server. With the CPU vulnerabilities, some of the older hardware is no longer as suitable for some roles, like virtualization in enterprise environments. But you know, could be perfectly suitable for home lab, like having a second gen Xeon server. So we can look at the kernel drivers that this kernel on the live CD is using, and sometimes get an idea some of the extra drivers that might be necessary, and a lot of them that, you know, maybe the live CD kernel isn't using because it's not used by something. That's going to be seen by some of these examples. Like AC battery, they're just arbitrarily loaded extra junk. You know, like SHA-256 encryption module, and they might not be used right now, but you know, that was included because it could be used by something else. Even if the CPU doesn't have a cryptographic engine included in the hardware, the Linux kernel does and can use those modules to perform those functions. So you know, like a bunch of random drivers for Ethernet devices that aren't included, that you know maybe need libphi, right, which is necessary for a lot of things. Or here's the BTRFS file system driver. Some of the software read drivers that get loaded. And some of that stuff's just good to plain just whitelist support. But have it modular, you know, have it optional. And Linux is really good at providing those features by making them modular, making them a driver, a feature that can be loaded when it's needed but is still available. So the modular environment is one of Linux's great achievements. And you'll see probably like after the system's booted, this whole list will be like half as long because it doesn't have to load a lot of that extra drivers and so on. Yeah, I had a bunch of older servers too, like I had a an Opteron, first gen AMD Opteron 64-bit server that I bought off of eBay a long time ago. And It was the first server that I had in a rack mount case, was in a 2U rack mount case, and I sent it off to be co-located and hosted in Chicago when I lived in Central Canada. That's also the server that I used for hosting my file mirrors for Gentoo back in the day. I had an official file mirror for Gentoo Linux that was listed on their mirror list. Not a lot to say while it's doing this. It's probably maybe 20%, 10% done. I'm guessing though, since there's no progress bar. So it's a bit painful doing this on an older machine, but it is what it is. So. Oh, now we're getting into block devices code. So while it's doing that, we can do some other things, right? Let's edit some of the boot configuration files. Yeah, why don't we? We'll just grab this. But we'll leave the UUIDs for now, just for a minute, and then use block ID, and we'll get the UUIDs for the file systems, and copy that into our text file. So SDA1, so this is a newer feature too, is that it will use these. Woo, I didn't want to copy all of that. I only wanted the UUID string, which I didn't copy before I pasted. So there's the one for the boot partition. Just try and make it nice and neat and even. And then we'll copy the UUID string for the root partition. Which would be SDA3. Paste that, and we'll go down to the UUID for the swap partition, which will be SDA2. And I'm going to set the root user password to the password that Koth gave me. So we don't forget to do that, because that's never fun when you end up getting in and your passwords don't work. And we're just going to check for updates and a couple other exploratory things while the kernel's building, just to get a general idea of anything that needs to be attended to. Running out of cigarettes. I left my cigarettes in my van, my other pack. So I guess it's vape time. Might get a little loopy off of this vape though. It's got funny juice in it. There, puff puff pass. So using screen really adds utility to this. Even though you get a text console, you've got 1,000 terminals you can use in one system. If you can manage them. Using screen. You got one logged in somewhere in Australia or something, right? And the next one after that is, you know, your backup server or whatever, like AWS instances and stuff. You can do it all from a live CD console. Oh, excuse me. Okay. So there's a couple global flags in here I want to add. I want to add caps. I want to add IDN. And a couple other generic flags like threads for threading support, so that some of these programs build as multi-threaded. It really helps the performance on a lot of different systems I've done this with. Any other ones? You can also see every flag for every installed package by going EPV world. World's just the meta package that defines all software installed in the system. To give you an idea, anything you want to change. Cron tab support for some packages. There's some new features in E2FS Progs, which is like the management programs for ext2, ext3, ext4, for some of the new stuff that's coming in for corruption detection, and that could be useful. Excuse me. I tried to screw this thing and it's like it's loose. Try to screw it shut and I guess it's not getting any air. I guess you gotta leave it unscrewed a little bit. Not really use the vape very much, but yeah. I'm pretty sure this too is using the new profiles that were stabilized for Gentoo Linux, which is 17.1. So that if it had not been done, likely would have been a necessary upgrade. And I can tell because some of these packages are noted with this split-USR flag. And that's something I've seen on some of those systems that I have upgraded to the new profile. Nope, it's still 17.0. So that's not fun. Maybe they'll release new build stages with 17.1. But that's fine. At least it's a systemd profile to start with. So, so use flags. As far as flags go, the standard set is defined by the profiles, and anything above and beyond that you want to add, later would be ideal, right? But later. So like start with whatever profile you're going to start with, and then if you're going to add desktop stuff within the same profile group, right? Like adding GNOME systemd, or changing it to Plasma systemd. You change the profile 9, and then it'll pull in that world dependency calculation. Will pull in all of those packages that are base recommended sets of software for building a desktop system, or a system that has desktop capabilities remotely. So I have several systems that can use X2Go server, and I discovered that last year, and it's been an amazing program that somebody put together that lets you use remote desktop via SSH access on Linux machines, and instead of running the system programs for the desktop on your computer on your desktop, it runs them on the Linux machine. It's just remote access, I guess, of course, and works really well on VPS instances. Here's something else that I'm going to add that you might like. In systemd, there is a new feature that was added to support using DNS over TLS or DNSSEC, and what that'll do is it'll let you configure systemd-resolved, which is the DNS resolver component to systemd, to make it use encrypted DNS, and that was just recently added to Gentoo Linux. So you can, you just change a feature like that and rebuild the package, and away you go. You can't do that with pre-built Linux. It might offer that capability, but there's no easy way to add it after it's been pre-built. Okay, so we'll exit our root and go back to the kernel build. And it's still going. It's getting down there though. So let's go back to the root and okay. So what we're going to do is we're going to make a network configuration file for systemd, and having a template, of course, is something that makes doing that really easy. we're going to go in F1. One, 3. Okay, so we can pretty much put something together from that. And there's an example in the Arch Linux forums for setting this for DHCP that's really useful and works for every system D installation that is configured this way. So we want to name it after the Ethernet interface name, so ENP 1S1.network. And then Putty makes this really, really helpful that you can copy the file name. What we're going to do is we're going to go like this, and that will whitelist a regex to configure the network via DHCP for every interface matching that interface wildcard string. So DHCP, right? I'm just looking for examples. So we can see it's a Boolean value, so it just accepts 4 or 6, but we're just going to let it, you do both and then whitelist it as yes. I think that's right. Or what we can do, I'll configure it static for you so that it's something that you'll always know what it's going to be, right? But I'll set it on a non-DHCP IP address. We'll go 55. Why not? You can change it if you got something else on there. So just Comcast DNS. Why don't we do this? Excuse me. Okay. use Cloudflare because that'll let you use the 1.0.0.1 DNSSEC stuff if you decide to. Okay, so that's a network config set. You know, you can see that with Gentoo, the tab control works with system control as well. Like you wanted. But maybe it's not set up properly yet. So here's all our system services. There's a couple that we have to enable, like SSHD. And the networking services for systemd. And that's pretty much basically it. Resolver. So it can resolve DNS. That's the only three you have to enable at first. Other things you might need. Because Gentoo has the root user accounts disabled for remote logins via SSH by default. So you can't log into root unless you use an SSH key. No, I'm not gonna backdoor this guy's server with my SSH key. So what I'm gonna do is I'm gonna add a user and add that user to the wheel group. And what that accomplishes is allowing that user permissions to access the super user root account via the local console instead of remotely. Just by adding this management script, which helps manage how users are created. Otherwise, you won't be able to log into this thing remotely. Okay. Because after it boots, there's setup steps that need to be done that either you can do, or if you want my help doing it, I'll help you with it. To set the host name, set the time zones, and that stuff just doesn't work with systemd until it's actually booted under its own power. Because I think its dbus is not running under the running kernel. So. Okay, so super add user, name user. Let me see here. We'll use the next available. Initial group will be users, and then wheel. No expiry. All the other stuff is irrelevant. I'm going to use the same password he gave me. There we go. So now you can log in, and then you can use su root from a non-user console to log into the root user terminal. And it's not using sudo because sudo isn't even added yet. You get the bare minimums. else I should do while I'm waiting. Oh, still going. So, if you know how to use a terminal console like I've been doing, you know, you can multitask pretty easily with just one. It's nice having two and some more screen real estate, but if you're really limited by having like a laptop, you know, you can certainly work in multiple different countries and multiple different servers at once with Linux environments. Unix is very much similar to this as well. Yeah. I have to say I salute you, friend, for wanting to endure this on a Pentium 4. That Pentium 3 won't be much better, but you know, it's as good as it'll ever get once you get what you want on it. It'll be as good as what you ever wanted on it. You know, if you want to do the CPU specific like compile tuning and all of that crap, you know, it could get a little bit snappier once it's booted and it's running under optimized program code. So, you know, a lot of the software that's built for computers, like I'm doing now, is built for generically built to run on every type of CPU. And you know, people buy these new expensive fancy CPUs. They'll get the K model i7. Oh, I want an i9 with the K. You know, so they pay for 75% more CPU than they're actually using because the software isn't built to actually utilize some of those features. It's all disabled by being randomly generic as it's compiled by the software compiler. So this permits you to build your software to optimize to utilize all of those SMID instructions. Yeah, there you go, man. You know, and some people get a spin off of that using the old stuff. You know, my one of my YouTube video projects that I did a while ago has let's see if I can show it on camera. Has this. Maybe you can see it over there on my desk by the door on the bottom of that rack of what looks like switches and routers is a Juniper appliance, and that Juniper appliance doesn't have a video card. It's all access to via serial connections to be able to do any sort of local admin on it. It's sort of like a Cisco router, pretty much, because well, it's Cisco Juniper. You know, that's kind of their intended purpose, and you know, or a server. One of you that I got with those, I got them out of a dumpster in downtown in Vancouver in a recycling bin. And you know, all of the stuff works. It's just obsolete. And I managed to get Gentoo Linux running on the Juniper appliance and replacing I think it's like CentOS 5, like totally obsolete and something I wouldn't even plug in on a network now. It's bad enough that CentOS still runs an obsolete kernel that's not even supported by Linux anymore. But you know, like 2-3 generations previous to their current release. So I wanted to do this to it, and you know, much like your Pentium 4, right? You know, you want to have some new software on it, be able to manipulate that software to suit the system you're going to use it with, and that permitted me to get that Juniper appliance running Linux with all of this new stuff. You know, there isn't a Juniper appliance that old in existence that runs systemd. So that has some merits, and there's a lot of tools with systemd that are useful for certain scenarios. Someone threw a toner cartridge on it. It might have been in the bottom of a recycling bin, like downtown somewhere. You never know. They've got these blue bins in the office towers in Vancouver, and they basically just throw the e-waste from all of the offices that have thrown junk out, and the guys come by and they pick it up in a half-ton truck, or larger, depending how many bins they have and whether they're going to open, empty multiple bins, I guess. I got, there was a bunch of toner cartridges and a printer and something, in that, the bin that I got those network appliances from. It may have just taken been dumped on. Somebody thought it didn't merit not staining. Now, fortunately, see, if you've got a new computer there, Koth, that you can run VirtualBox on, what you can do is after this is built, you can clone the install into VirtualBox on, say, your Windows PC, and you can use distcc, and that'll let you do, network compiling. So it's a distributed compiler program that distributes compile tasks that are run by the software package manager to secondary Linux systems on an IP network. So, the older machines that, like your Pentium 4, when I did builds like this, besides the kernel, we would frequently, back in the day, we'd use distcc because, one just wasn't enough. Or in the Pentium 4-ish era, distributed CPU processing for building clusters was pretty common, like OpenMosix. I built a few OpenMosix clusters back in the day, and that basically was a kernel patch. And what it would do is every additional computer that you had that kernel patch on, that was labeled in its process group, or like farm family or whatever you call it, would accept and retransmit back to the other computers that transmitted them process jobs to compute. But distcc is kind of like that in many ways, but it only works with compiling software specifically. So I don't typically use distcc very much on my newer machines because you don't really need it with a dual 20-core Xeon. You know how to configure it all. And once you install it and just run the basic commands, it pretty much just works. But you have to add the keyword for it to the package management system, the make.conf file, where it says features. You add distcc and a space, and that'll enable distcc, so that the package manager will use distcc and the configuration files that are configured for it. But the kernel will generally go about as fast as it can. See, I had a virtual machine that I rented from OVH Data Center sometime, I don't know, the last previous 2 years, and I just don't need it anymore. But it accomplished what I intended to want from it, was to learn some more networking labs by having a remote Linux server, and that machine had only 2 CPU cores on a VPS, sometimes 1 maybe, and I'd run like J15 parallelized compute jobs, because using my Xeon server at home to compile software for the VPS and the VPS would just transmit all of those distributed compile tasks to my server on my home network, and then back to the data center. So it works over the internet as well, but certainly over a local network's more ideal usually. Now, I have a suspicion that this is going to fail, and I think I know why. But if it fails, we can just resume. I forgot to edit out one thing that I'm going to check and stop it. This. This is the firmware for the Intel microcode update. The microcode patches for the security vulnerabilities. Linux firmware and so I have to adjust a couple of use flags on these packages, specifically for the Intel microcode package, because I only wanted to install the firmware for just this processor, and that makes it easy to find out what that string should be. So what we're going to do is we're going to add a keyword, and you saw me mentioning that keyword file earlier. Package.use. And this will apply these package features to this package and every version of this package. Linux firmware package is good to have too, and is not installed yet. So we will definitely install that. And then we'll go back to building the kernel. Now the reason why I did that too is because that the firmware wasn't going to be found when it got to that stage of the kernel build, and it would just error install because it couldn't find the files. They don't exist. The package isn't installed that provides them, and they were from the kernel config from my server that has different CPUs, so different microcode files and file names. Maybe I can move my mic out of the way a little bit here. There we go. Try and move my webcam pick around a little bit. Good enough. Okay. So we've got our firmware files now, which will be in lib firmware. Yes, there's a lot of them. Intel, Ucode, and that's our firmware files for this processor. And there's a lot of them. So what we'll do is we'll make a string for the firmware. And the directory is relative to its parent, so we don't need the full path. This will patch all of the security holes in the processor, at least while it's running, until it's booted next and applied. So it's not a permanent fix, it's just a software update for the processor, which is what microcode is capable of doing, or is intended to do. And take all of that and review it and make sure it is correct. So that'll get built into the kernel binary. Oops, we won't be caps lock. Generic driver options, firmware loader, and we can see that our string is in the kernel config UI because we edited the text file. Makes it a lot easier because this doesn't wrap, and you have to edit this string pretty much like this every single time you want to add something. And you can't really see it all; it's easy to make mistakes. So. Change Linux specific options. So we want to make sure we've got support for the legacy and systemd init systems. So OpenRC. We'll just make sure that's included too, and it is because my config is used as a template. Now on a faster system, I would clean the tree and rebuild it all, but it's not an option that's going to affect how the C code is built. It's just going to affect those firmware files being packed in with the final binary. So in this case, it should be all right. You know, and this is really cool too. Is you can't do this with other operating systems. Linux, Unix being the ones that you can, right? The other ones, Microsoft and whatever else, Mac, you can't recompile your kernel, your bootable driver set to alter it or modify it at all. And you just kind of have to rely on them to provide something that works. And a lot of Linux is like that too, right? You know, there's a lot of ways you can change things, but maybe changing them might not result in something that's going to be altogether stable long term. Like having a lot of random stuff with the package manager, for example, on a lot of distributions can cause, what's the term for it? Not isolated, but like leftover libraries for programs that shouldn't be there, that don't match certain versions of software that could use them, so they'll throw an error and not work. Consistency is big with Linux, and that's why a lot of pre-built software it's a lot of the time consistent. But when they give you something that's not consistent and has a build error, and they don't catch it, you're left with a few ways to be able to fix the issue yourself. Because the software package manager doesn't rely on a software compiler. With Debian, with Ubuntu, with all the other major ones. The package manager for Gentoo relies on a software compiler. You know, or there's a lot of software too that you don't have to compile, you can still install. But you know, it can all be managed easily through the script templates to make those functions happen and install programs. And it's all written in Bash. It's pretty much the most basic programming language available for computers today. That's extremely proficient at doing many things. So this is probably going to take a while, but my friend Koth, I think that you probably got all of the unknown issues worked out with your server so far. I don't see any reason why it shouldn't work. You'll probably have Gentoo booted on this thing later tonight. And, you know, from there, just final setup. The kernel's going to take the longest, and the updates to get them done. But you don't have to do the updates right away. You know, there is packages that need to be installed. Like DHCP daemon, cron daemon, EIX, UFED, you know, and all of that stuff. What else? There's a couple other random utilities too, like Gentoo Kit is a Gentoo specific management utility that provides config file management and inconsistency checking utilities. So about 6 packages on top of this. Base install in kernel and install and configure grub, and you're pretty much done. But as it stands, yeah, sure, man. You know, I can kill the stream for now and just let this go and check on it in half an hour. Message me when you're back. It'll probably be a good half an hour at least before this kernel's done. I have to guesstimate. But maybe we'll fire up the stream when we're back and we'll see how it works. Okay, yeah, chat when you're back, dude. I think I'm gonna go I'll watch some reruns of House, but we'll be back later and continue up with part 2 of this, finishing up Gentoo Linux installation on an old HP server with a Pentium 4 in it. Pentium 4 CPU running in 64-bit mode. So it is a newer Pentium 4. I remember not much about Pentium 4s. If you had an older Pentium 4, you'd really be hurting because it only it is what it is. You can still make old hardware useful. So, cheers. See ya. Back later. Compile long and prosper.